This is my 3-meter Fox motor glider, which I've had for about 4 years now. Recently I've made some changes to the glider, and this video is about the changes that I've made to it. Just had a look on the web and it's still possible to buy the Fly Fox. Comes in 2 versions. There's the free fly glider, and the one beneath it is the motor glider. From my experience, unless they've corrected the problem, I would advise anybody to buy the glider version. Cut the nose cone off in the right position and fit your own motor mount. My first problem with the Fox was that in the electronic version, the electric powered version, it came fitted with a motor mount, and there was just way too much offset built into it. So what I've done is I've drilled out the original motor mount. I've had to fashion my own because it wasn't a circular shape. I could have used a standard off-the-shelf one had it been, and I've epoxied that in so that it does not have any offset at all now, which is exactly what I want. Behind the motor mount is a 35 by 48 electric motor. It's 900 kV and bolted onto the front of the prop shaft is a 13 by 10 propeller. It's a folding propeller. The propeller just fits onto the shaft like that, and is then tightened with an Allen key on this side, and then tightened on that side. It's a good design, this one. And then the spinner just fits on the front like that, and it would be held in place by these 2 little screws that go through a couple of little holes in the bar and hold that nice and secure. I fly the Fox using 2 different sizes of battery. The one that's fitted in the glider at the moment is a 3000 milliamp battery. That's a 30C battery, and that just clips onto the throttle controller. I'm not going to attach that because I've not got my transmitter switched on, but that goes in there and that goes in there, simple as that. With this arrangement you can see I've got 2 batteries together. These are 2200 milliamp batteries, and at this stage they're completely separate. There's no way that I could harness those 4 cables, those 4 power cables, to the 2 that I've got coming out of the throttle controller. So what I've done is I've made a couple of Y harnesses, one in red for positive and one in black for negative. So if I slip those on the negative like this, that goes on there and that goes on there, and then I pop this on to that one and that onto that one. I've coupled these 2 batteries up now, and it's left me with 2 gold connectors that fit into the connectors on the throttle controller. So effectively I've turned 2 2200 milliamp hour batteries into one 4400 milliamp hour battery. This is the location of the throttle controller. It's a 60 amp throttle controller, and this is the location of my receiver. This is the size of wheel that I've now fitted to the Fox. I had previously been using that size of wheel because I was flying it off the ground into the air and I needed the prop to be able to clear the ground. But as I'm going to make it a hand launch aircraft now, that should do me fine. On the plans it shows that the servo for the horizontal stabilizer actually fits inside a space that they've made on the horizontal stabilizer. What I have done is I've cut out a hole in the side of the fuselage. I I stuck a servo to the inside of a plate like this one with four screw holes in it, and I've embedded the servo inside the fuselage and screwed that plate to the side of the fuselage. So there's a control rod that's attached between the servo arm and the control horn, and that's what gives the horizontal stabilizer stroke elevator the control that it needs. I'd fitted the metal control rods for the rudder, but I found them a little bit resistant, fairly hard to move, and the connector ends were very industrial and out of proportion to the plane. So I've just gone with control wire, nice and simple and light and very fluid, moves beautifully, no resistance. You can see as the fuselage gets towards the tail end, it gets progressively thinner, and by the time that it gets to the horizontal stabilizer, it's at its thinnest part completely, because the horizontal stabilizer has to fit onto the fuselage, which is about the width of this cutout here, where these two screws attach it to the fuselage. And what you need to do, or what I needed to do, was make sure that the horizontal stabilizer is exactly the same on the horizon as the main plane, as the wing. And unfortunately, as you tighten those screws up to make this nice and rigid, it throws pressure onto the horizontal stabilizer, and it was virtually impossible to try and get it so that it lined up exactly with the main plane. To resolve the fixing problem of the stabilizer, I just bought some L-section plastic, which is very, very light, from a local hardware shop, and hacksawed it to size and fitted it underneath the horizontal stabilizer and glued it to the fuselage, so that the stabilizer had a bigger support to seat on than was just the case with the fuselage alone. To fine-tune the horizontal stabilizer so that it was perfectly aligned with the wing, I used this plastic sheet, which I cut into little strips, and with these in place underneath the horizontal stabilizer, I just kept adding them to each side of the stabilizer. That's this side and that side, until the alignment was absolutely perfect. Fly made the flaps on this RC Fox from this point here right the way around to this point here, leaving only from here to here for the ailerons. So the flaps were too big and the ailerons were too short. What I have done is I've changed things a little bit, and I've shortened the flaps, so effectively this is all I've got. I've fastened with epoxy this part of the flap to the wing here, and I've cut it here so that this is all the flap that I have now, because the purpose of that flap really is just to create drag, because I want to, if possible, reduce the glide on this wing when it's on approach, and also when I'm flying I want better performance with the aileron. So instead of the aileron being from here to here, I've taken some of this which was flap and secured it with epoxy and carbon rods on the underneath section there, and made it an aileron. So that's the length of my aileron now, and this is all I've got for flap. So when I test fly, it'll be interesting to see just how it performs as against how it used to perform. I've just completed the edit on GoPro Studio for this video, and the time on it is over 10 minutes. I was going to add flying sequences to it, but the video would run too long, so I'm going to make this a part 1. If you'd like to see the airplane in the sky, look for part 2. It's not currently made, but hopefully I should have it completed within the next 2 weeks or so.